Okay, lecture BO3, Interaction of Architecture, Architectural Design and Facades. I do this by a city walk through Chicago, and I will in the end show 3 samples which I find rather interesting and like to share with you as a system. Chicago, we could do that in any other city. It could be Amsterdam, Rotterdam, or could be Frankfurt or Munich, it doesn't matter. Yeah, I had a trip to Chicago. I took some pictures, and this is a nice wrap to wrap up to express this. And it starts with obviously Chicago, Frank Lloyd Wright, Oak Park in Chicago, where he did his first buildings, or one of the main set of buildings. And we see very simple stapled bricks, very horizontal oriented, having a certain aesthetic, quite solid structures, but just across the street, we also see this kind of structures where the same architect obviously was less technically interested in or aesthetically interested in the design, just made a certain design. And when we take the left side picture, we can identify, naja, it doesn't really get a tectonic organization of the forces and the aesthetic being organized. Obviously, the owner wanted to have a certain window, a bay window in this situation, versus the roof, which aesthetically needed to transport its loads down into the system. And you can imagine, technically speaking, there are loads which have to be brought aside with additional components, which is not the pure tectonics to be developed. Interesting experience. Then he changed his attitude from expressing the technology of the object into this more form-oriented architecture, plastering the structure, and by that wrapping the building towards a more geometry oriented than technically oriented or technical appearance oriented design. I continue with that one. This is one of the very rare brick high-rise buildings, actually the only one in Chicago which is left over. It's a high-rise building of what, 20 floors or something, which when it is done in bricks obviously delivers a lot of dead loads, which comes down to the bottom, which means that there's a certain thickness necessary to get these brick structures built. So the interaction of the solid structure, the entire structural solid structure being a solid structure, and then as a consequence the dimension which is necessary to be used in here. One of the very rare buildings, versus these buildings where we see they are, say, having the same dimension at the top part as well as at the bottom part in the outer cladding. And here I call it cladding because we know there's a steel structure behind, and that steel structure is then wrapped with a natural stone or artificial stone or brick set up to clad. It aesthetically delivers some similarity to the pure brick and dead load oriented buildings, but we now understand by the dimension of the windows that this needs to be a skeleton structure which is behind. The same here. It follows a certain aesthetic. It even follows this aesthetic when we look at these, say, arch-like systems. But as we now know, there's a steel structure behind, and all these natural stone components which look like being dead load oriented are fixed to this substructure, so they're not taking the dead loads of the main system, which we identify by the dimension, the similar size of windows through all the floors, quite a dimension which expresses that the dead loads are not taken by the outer layer, but by an inner structure as a system. Interesting wise, this could be done in natural stone or artificial stone or bricks. Sometimes we see this. This is a concrete structure, and again we understand that this arch is supposed to take the loads down. It's a concrete structure, but when we look closer to it, we see there's the joint here and there's the joint here. So it's actually a T-section prefab component made in concrete, then connected to each other. This creates the entire structure. So there's some, say, aesthetic, which seems to follow a dead load structure to organize forces down. But when we dig into the technology, we understand it's a different technology, which just mimics a certain aesthetic, but doesn't really follow it as a technical solution. And then Industrial Revolution appears. All the steel structures are getting more prominent. Architects allow them to be more visible, as we see here from Louis Sullivan, the first project, and then this one, which clearly expresses, it has a certain aesthetical identification, which is linked to stone, artificial natural stone aesthetics, but technically speaking, the size of the window, the slenderness of these columns express clearly there's a steel structure behind, which is used as the main support. This goes on with building of the 1920s, and then Mies van der Rohe appears, and he transfers this steel into a more visible component. He allows steel to be the structural component, but also being visible as a structural component. The IIT, Illinois Institute of Technology campus, where he did his campus buildings, where he did this very prominent Mies corner, the main structure, the column, and then a facade component, which actually is then wrapped with glass and bricks as a unit, and then this whole thing, one layer facade, the other layer of facade, and then the inner structure, which is made visible even at the base, visible to the outside, inner structure, then the steel structure of the facade, steel structure of facade, and then the masonry. You can imagine that it's getting quite cold in Chicago. Technically speaking, the insulation of this is an issue and needs to be considered, which we see later in some of the slides to come. The crown hall, the super prominent crown hall from Mies van der Rohe, following the same attitude of the Mies corner. We see the facade, the main structure, and the facade being connected to this typical Mies detail, ventilation flap at the inside of the crown hall as a system. He continued following this aesthetic, was able to build lots of high-rises in Chicago. We see again same setup of Mies corner, main structure, and then the facade itself to make it more visible that this is an additional component. He even added this technically not necessary steel eye sections on top of this. It appears to be very, say, industrialized as aesthetic, but it is still on-site manufactured, which is, say, a difference to the current facade technology, which we see in later lectures of the system. Another experience which we can identify clearly here is this is still solid steel as a system, so solid steel structure. And again, if this gets cold, it gets cold at the inside as well. They learned this problem and started insulating it. So the main structure is now insulated with an additional layer, still appears as the Mies corner, which we see here, this outline, and still the same type of facade being used. Aesthetically, with this eye section, you see the slenderness of this eye section expresses to us. It's actually technically not giving a lot of additional functionality to it. Interesting wise, this is, say, used from other architects as well. In SOM, they started using the same aesthetic of adding these lines to create this shadow, which was expected to happen on a certain surface. It goes on like this. Then Mies comes with more free-form geometries like this. And what we clearly see is main structure is behind, and then the facade are a curtain wall hung in front of the main structure as a principal system. Other architects, again, copying this aesthetic of the Mies corner, main structure being insulated, then the edges of the structure, then additional components to create a certain depth, a certain appearance of the facade with, say, questionable technical need, but aesthetically delivering its functionality. It goes on, SOM John Hancock, same situation. Again, we see main structure being entirely wrapped for insulation purposes, and then the facades appearing quite industrialized, quite prefabricated, and then the final additional lines to create a certain slenderness in the appearance, but not from a technical background. Goes on with CS Tower, following the same kind of aesthetics qua corner, and we also see very nicely here the facades itself are actually getting very, very slender in comparison to the main structure behind. So we see huge columns, main structure taking down all the loads of this 400 meter, which is obviously a lot of load. And then the facade being very slender in front of it, just wrapping the inner environment versus the impacts of the outer environment as a system. It continues with some concrete structures, Marina City prefab concrete components, another prefab concrete component done by the same architect, River City, somewhere in the 1970s, 80s, as said. And then a new generation of architecture appears with Helmut Jahn. This is an inner courtyard, an inner space. This inner space being wrapped with a more modern facade, more relying on silicon as a sealant, trying to overcome this typical aesthetic of floor window geometry. And this follows up in this one project, which is done with structural glazing. Structural glazing, and that idea means that the glass itself is laminated on a substructure, and it's laminated with silicon, so it's actually not the glass which is structure, it's the silicon which is structure, so we better should call it structured silicon, but that's, history creates certain names. This structured glazing delivered the opportunity to create these shapes, which do entirely disappear in the surface. They even argued that these facades are made so much mirroring facades that they actually mirror the opposite and not visible as buildings. But the idea, the intention behind is to get rid of floor slabs, opportunities to identify certain situations, certain windows, certain positions, just to have volumes in the city, and not volumes in the city made out of a pattern, a surface to appear. What happens behind of these kind of structures, just to express, this is a hospital. I took pictures of, this is the steel structure. Steel structure is sprayed with plaster for fire resistance reason. We see the dimension of this steel structure, and we see the dimension of the artificial stone cladding, which expresses a certain dimension, which feels solid for us as architectural appearance. But we know the structural design, the structural components behind are a lot different. Quadriometry, quad-dimension, taking down the loads. And then we see a substructure for a facade to be installed in the next step. Modern architecture, or modern architecture appearing in this. This is an OMR campus building, which they bought in as a nice brand for the IIT campus. Here the idea is dealing with different materials, expressing in a certain very expressive architecture the geometry of the building. It's a huge tube which allows a highway rail system to get into, unload people, load people, and then these people disappear within this campus center. And the aesthetic used here is not expressing a certain technology or expressing a certain geometry. It's more about showing different types of materials. So if you go back to the inside, you see it's mainly about appearance of materials. It's mainly about expressing a pattern, a collage of different types of materials. It goes on with even this one, even more modern piece of architecture. It's a freeform object. It's a steel skeleton object, which is entirely wrapped with a stainless steel surface. Technically, we are kind of unable to create this out of one volume, so it's actually welded stainless steel plates, and then the welding lines, which we can imagine here by the mirroring effect, is polished and polished and polished to a certain quality to create this kind of appearance. It goes on with this type of freeform architecture, which we also find in Chicago as an object to, find a new position, find a new aesthetic, and a new architectural design aesthetic as a system. This was an historical and technical and aesthetical city walk through Chicago. But as this is named Interaction Architectural Design and Facades, I'd like to also address three other projects which I find super interesting, and I'd like to show. It's one from Frank Lloyd Wright, which is this Johnson & Johnson Wax laboratory building. This is the tower is a laboratory building. They have in each of these horizontal windows, they have two levels of lab buildings, and Frank Lloyd Wright wanted to have this certain aesthetic as an appearance, which he in the end designed out of glass tubes because he wanted to use something new. So I actually started stapling glass tubes on top of each other, and you can imagine the joint between these glass tubes, the interface. That's something which is super interesting. Nowadays we would do this with say silicon profiles to create a watertight connection. At that time this wasn't possible, so they actually in the end filled it with a mortar-like material, which would work in a vertical solution, but you can imagine at the edges, what we see here in this picture, this starts to leak for sure. And any horizontal structures, that must be a disaster. And as we see in this picture, which I took as a close-up, the horizontal structures, that's not nice to deal with, which is what happens here. And at pretty much horizontal areas, they even cover it with polycarbonate plate to solve it. So it's say this aesthetical idea, the technical idea, and then the technical solution. That's the interaction which we need to face. Similar Farnsworth House from Mies van der Rohe, where we see when we look at this, we feel like, oh, we are so jealous that they were able to get so slender structures. When we look at this, and it's in the north of Chicago, so winter time is getting very, very hard. It's a single layered glass surface with no insulation value, which means it must be super cold at the inside of this building if you're staying in this house in wintertime, which you obviously didn't do because it technically didn't work out well. With just one layer of glass, you're able to create very slender steel structures which are craftsman manufactured, brought in position, built at the situation, and then as we see here, even screwed in position, which we would not be able to do in our modern IGU insulated glass unit systematic, where we have to take care of any energy transport within this system. Interesting experience. So super nice architecture at the level of its time, but nowadays impossible because of, say, the technical demands which we see for the solutions nowadays. Another one, not in Chicago, this is in Los Angeles. Walt Disney Concert Hall, Frank Gehry, a super free-form structure. We see this aesthetic of this free-form structure. We envision that there needs to be a shell-like structure behind, but technically speaking, it's a skeleton structure, which we see here, main skeleton structure, which has a first secondary structure, second secondary structure, third secondary structure, which then allows to position on a final secondary structure the Schindel system. That's the Schindel system which we see here, the Schindel system on top of this structure. So technical solution for creating this geometry, but when we think about it, it looks like shell. We now know it's a skeleton structure, so there's still some opportunities, some openings to get this next level of advanced architecture to create a real shell structure, which then would create a lot less technical complex geometry, complex technical solutions to create this free-form geometries, just as a thought of the interaction of the architectural and the technology design within these buildings. And with this one, I stop this lecture and hope you liked it.